Hello guys, welcome to Maths Minders Academy. In today's lesson, we'll be exploring the area of rectangles and triangles made easy. But we're not doing it the boring way. Oh no. This exciting math adventure unfolds through a fun animated story featuring James, Sandra, and their brilliant math teacher, Mr. Bob. Watch closely, follow along, and enjoy as the lesson comes to life right before your eyes. Let's begin our journey into understanding the area of rectangles and triangles in the most enjoyable way possible.
It was a quiet afternoon, and James and Sandra were reflecting on what they had read about area in their math textbook. Sandra, looking up from her notebook,
James, I read something interesting. It says the area of a rectangle is its length multiplied by its breadth, or width. But the result is always written in square units like squared centimeters or squared meters. But how does a rectangle contain squares?
James thought for a moment. He had read something too that he did not understand. So he said,
I also read that the area of a triangle is half base times height. That's okay for right triangles, where the height is easy to find. But how do we find the height in other types of triangles, like scalene or acute angled triangles?
The two friends knew exactly who could help. Without hesitation, they agreed to visit their math teacher, Mr. Bob, a dedicated and hardworking middle-aged teacher who had always encouraged them to engage in personal reading and exploration.
Let's go ask Mr. Bob, our math teacher. He always explains things so well.
With questions in hand and curiosity in their minds, James and Sandra rode off to meet Mr. Bob. James and Sandra arrived at the classroom, where they found their math teacher, Mr. Bob, standing by the board. James was the first to speak.
Sir, we've been reading about the area of rectangles and triangles, but we're confused about a few things.
All right, James. What exactly did you read that left you confused?
At that moment, Sandra leaned forward, ready to explain the questions on their minds.
Yes, sir. There are two main things we don't quite understand. Why is the area of a rectangle measured in square units, especially when a rectangle doesn't look like it contains squares? How do we find the height of triangles like scalene or acute angled ones, where the height isn't clearly one of the sides?
Mr. Bob nodded with a smile.
Excellent questions. I'm really proud of you both for thinking deeply and doing your own reading. Now, let's head to board together. I'll walk you through everything step by step. Ready?
James and Sandra listened eagerly, their eyes lighting up with curiosity. Mr. Bob smiled warmly, clearly impressed by their interest, and turned toward the board to begin his explanation.
We're going to learn the formulas for finding the areas of squares, rectangles, and triangles. To find the area of a rectangle, we need to know its length and its breadth, also called width. Once the length and width are known, we can calculate the area by multiplying length by width. For a square that measures 1 centimeter by 1 centimeter, the area is also found by multiplying the length by the width. That's 1 centimeter times 1 centimeter, which equals 1 square centimeter, written as 1 centimeter to a power of 2. Can squares perfectly fit into a rectangle? To answer that question, let's consider a rectangle that measures 2 centimeters by 4 centimeters. The area of this rectangle is 2 centimeters times 4 centimeters, which gives us 8 square centimeters, written as 8 centimeters to a power of 2. This rectangle can be filled with 8 squares, each measuring 1 centimeter by 1 centimeter. Let's try our formula on one more rectangle. This rectangle measures 2 centimeters by half a centimeter. To find the area, we multiply. 2 centimeters times 1/2 centimeter equals 1 square centimeter. But wait, how can the area be 1 square centimeter when the shape doesn't even look like a square? Well, this means the total area is equal to that of a 1 centimeter by 1 centimeter square. If we divide this rectangle into 2 equal parts, it would form a square. This shows that rectangles can be broken down into squares of different quantities. For example, a rectangle with an area of 10 square centimeters can be divided into 10 squares, each 1 centimeter by 1 centimeter. So, now do you understand how rectangles can actually contain squares?
Sandra nodded her head and said,
Oh, I get it now. So even if a rectangle doesn't look like it's made of squares, its area still tells us how many 1 centimeter by 1 centimeter squares can fit inside. That's why we call it square centimeters.
Excellent, Sandra. That's exactly the point. I'm really impressed with how you reason it out. When we break down shapes into familiar units like squares, it helps us understand area better. You and James are really thinking like mathematicians.
Mr. Bob smiled and nodded in approval. Then he turned to James' question. He was going to explain how to find the area of triangles, even when the height isn't one of the given sides, like it usually is in a scaling and acute angle triangle.
Now, we're going to learn the formula for finding the area of any triangle, whether the right-angled, acute-angled, or scaling triangle. Let's begin with a rectangle again. Imagine we have a rectangle like the one shown here. If we cut it along one of its diagonals, we'll get 2 right-angled triangles. Each of these triangles has exactly half the area of the original rectangle. That means the area of a triangle is half the area of a rectangle. So we can start with the formula for the rectangle's area. Area equals length times width. Since a triangle is half of that, we write area equals half times length times width. Now, when it comes to triangles, we don't usually call the sides length and width. Instead, we say base and height. So the formula becomes area equals half times base times height. And this formula works for all triangles, as long as we know the base and the corresponding height. Sometimes the height of a triangle is found inside the triangle, like in the case of acute-angled triangles. Other times, the height lies outside the triangle, like in obtuse-angled or some scaling triangles. And in right-angled triangles, the height is one of the sides itself. No matter where the height is located, the formula for finding the area of a triangle remains the same. Area equals half times base times height. Once you know the base and the corresponding height, you can simply plug them into the formula to calculate the area. It's also important to remember that the height of a triangle is always perpendicular to the base, meaning it meets the base at a 90-degree angle. You'll now see 3 different scenarios on the screen to help you visualize this. When the height is inside the triangle, when it is outside the triangle, and when it is one of the sides in a right-angled triangle. In each case, the height forms a right angle with the base.
James nodded with excitement and said,
Wow, this is much clearer now. I never thought of it this way before. But sir, Can you show us how to find the area of different triangles, especially when the base and height are given, or when we need to find the height?
Excellent question, James. I'm really glad you're thinking this way. Yes, I'll show you how to handle different triangles, whether the height is inside, outside, or when you need to find it yourself. Let's take them one at a time, and you'll see how simple it can be.
And with that, Mr. Bob turned to the board, ready to break it all down. He picked up his marker and began with the first example, where the height lies inside the triangle.
Let's begin with the first example, where the height falls inside the triangle. This is a triangle where all the angles are less than 90 degrees, what we call an acute angle triangle. Look at this triangle. The base is 6 centimeters, and the height, drawn from the top vertex down to the base, is 4 centimeters. To find the area, we use our formula. Area equals half times base times height. That's half times 6 times 4. Half of 6 is 3, and 3 times 4 gives us 12. So, the area of this triangle is 12 square centimeters. Now, what if the triangle has one really wide angle, greater than 90 degrees? That's an obtuse angle triangle, and in this case, the height can't fit inside. So, we extend the base and drop a perpendicular line outside the triangle. Here, the base is 8 centimeters and the height, measured outside, is 5 centimeters. Again, we apply our formula. Area equals half times base times height. That's half times 8 times 5. Half of 8 is 4, and 4 times 5 gives us 20. So, even when the height is outside, the area is 20 square centimeters. Same formula, different triangle. For our final example, we'll work backwards. Let's say the area of a triangle is given as 24 square centimeters, and the base is 6 centimeters, but we don't know the height. We still use the same formula. Area equals half times base times height, so we plug in what we know. 24 equals half times 6 times height. Now half of 6 is 3, so we have 24 is equal to 3 times height. To find the height, we divide 24 divided by 3, which equals 8. Therefore, the missing height is 8 centimeters. Now that you understand how to find the area of rectangles and triangles, I've got a little challenge for you. Take a look at this shape, designed like the letter E. It's made up of several rectangles. Can you figure out the total area by breaking it into smaller parts? Go ahead, team up, and see what you come up with.
As Mr. Bob stepped aside, James and Sandra leaned over their notebooks, pencils in hand, eyes full of focus. This wasn't just another math question. It was an adventure in thinking. With each sketch and scribble, they weren't just solving problems. They were discovering how powerful learning could be. Together, with curiosity, courage, and a little bit of guidance. If you enjoyed this fun math adventure with James, Sandra, and Mr. Bob, why not keep the learning going? Subscribe to Math Minders Academy for more exciting lessons, fun stories, and clever challenges. Like this video, share with your friends, and don't forget to tap that notification bell. And hey, head to the comment section and tell us, what was your favorite part of today's math story? We'd love to hear from you.
We'll let go of all that we know and dance in the stardust gentle flow. Dancing in the stardust.